Hello, am I audible? Hello. Hello, am I audible? So, hello all. Uh, my name is Manoj Shikhar, and I welcome all of you to the live session of Solid Mechanics Week 4. I'm a PMRF scholar at IIT Delhi. I'm in the Department of Applied Mechanics, and I have done my BTech and MTech from IIT Kharagpur. So, in Week 4, there were two lectures which have been uploaded on the website. And we will solve the questions related to those two lectures, and there will be a few concepts which have been taught earlier in the course, like in week 1, week 2, or week 3. They will also be utilized while trying to solve those problems. So as we do in all the classes, first we will try to recapitulate for a few, like for the important topics of whatever has been covered in last week. And after that, I will move on to solve some problems. Just let me check if the recording is going on or not. Recording started. see if I... Oh. So the topics which have been covered in this week are Mohr circles has been continued. Then sir discussed about stress invariants. Then we decomposed the stress tensor into deviatoric component and hydrostatic component. Sir has also discussed about octahedral stress. Then in chapter 11, concept of strain tensor and derivation of longitudinal strain was covered. Now, for the notes of whatever lectures which are getting uploaded on NPTEL, you can visit this website of Professor Ajit Kumar. And from there, you will be able to find notes. And those notes also have some questions. They have some questions at their end, which if you practice, you will be able to find similar kind of questions in competitive exams. And that will help you to score good marks in those competitive exams. So now it is X5 now, so I will start. So first we will see Mohr circle. Just turn myself. So what was the requirement for Mohr circle? One of the axis of the coordinate system in which representation, I should write matrix representation. Matrix representation of stress tensor is given. Good. Here it should be at least one of the axes. At least. Be perpendicular to at least one principal plane. What does this mean? This means that the axis, at least one of the axis of the coordinate system in which you are writing the matrix representation of a stress tensor, it should align with at least one of the normals of the principal planes. So there are three principal planes. So there should be at least one of the principal plane whose normal should be in the same direction as one of the directions of the coordinate system. So for example, which I will, so if we have a stress matrix representation of this form, Why did I delete it? Because from angular momentum balance, sigma 1 2 is equal to sigma 2 1. And thus these components are 0 because sigma 1 3 and sigma 2 3 were 0. So in this case, the axis, one of the axis is aligned with, like the third axis, E3 is aligned with one of the normal of principal planes. Okay. Suppose if it was written in E1, E2, E3 coordinate system. Now, if we are given, let us say, if we say that E1 is aligned with one of the normals of the principal plane. So what will happen? We will have sigma 1 1. Now, since E1 is aligned with one of the principal with the normal of one of the principal plane, that is E1 is a normal to one of the principal planes. So the shear component will be 0. So sigma 1 2 and sigma 1 3 are 0. Sigma 2 2 will be present. Sigma 2 3 will be present. So similarly here it will be sigma 2 3 and sigma 3 3. Here E1 is aligned with one of the normal. E1 is aligned. What if E2 is aligned? If E2 is aligned, sigma 1 1 will be present. Sigma 1 3 will be present. So in this case, E2 is aligned with him. So the thing to keep in mind is to apply Mohr circle, at least we should have one of the directions in which off diagonal terms will be 0. So in this case, you can see the third column and third row is 0 except for sigma 3 3. In this case, you can see the first column and first row is 0 except for sigma 1 1. And the same is true for this sigma 2 2. I hope I am able to convey whatever I wanted to say. Now, suppose we are given suppose we are given a matrix representation of a stress tensor. Suppose by any chance, if sometimes I write a stress matrix, consider that I'm meaning that matrix representation of a stress tensor. Okay. So if I do that thing again in the future, just remember that I don't mean stress tensor there. I mean matrix representation of a stress tensor. So we are given a stress tensor. Okay. Let us assume can we apply Mohr circle here? No, we can't apply concept of Mohr circle. I have already stated the reason why can't we. Now, to apply the Mohr circle, we have to do one thing. Suppose we are given a stress matrix like this. So how do we draw Mohr circle here? So we will first discuss the steps one should follow to draw a Mohr circle. Now, why do you want to draw a Mohr circle? The question arises that there. So the Mohr circle will help us to find out the stress components on a plane which has been rotated by some angle alpha from even axis. Now alpha can be clockwise or counterclockwise. So suppose we want to find stress components on a plane making angle with normal and making angle alpha with even axis. So this is what this is written in E1, E2, E3 coordinate. So we have a plane, its normal is like this, and this is E1 axis, let's say. So this is the angle alpha. And we want to find what is the sigma n here. And by convention, tau will be in the 90-degree counterclockwise. So this will be tau. Okay, so we want to find sigma n and tau. Steps to draw Mohr circle. Step one is find the center. So center of Mohr circle will be sigma xx plus sigma yy by 2 comma 0. So this is the center. Then draw sigma xx and tau xy on that is for even plane. Like sigma x is what? Sigma x is the normal stress on the even plane. Sigma yy is, sorry, tau xy is shear stress on even plane. It is sigma n and tau on even plane. Okay. Now, third will be join the center. And the point we have just drawn in step 2 and then by this link. And the point we have on in step 2. What this will give? This will give us the radius. In step 4 is, you know the center, you know this radius. So draw a circle radius found in step 3. From center found in so this is how you draw a Mohr circle. Now you have to find the stress on a plane which is at an angle alpha in counterclockwise direction for this question from even plane. So I will also write it graphically soon. I'm just writing the steps for now. Now to find sigma and tau, find sigma and tau on a plane in angle alpha from even plane, comma, alpha counterclockwise. Okay, counterclockwise. So there move on Mohr circle by an angle 2 alpha in clockwise direction. Now suppose if the plane was in the clockwise direction at an angle alpha from even, then in that case we will move by angle 2 alpha in the counterclockwise direction on the Mohr circle. So now I will represent those steps graphically here. So first we know that sigma yy is somewhere here. Let us assume sigma yy is here. We have sigma xx here. So where will be the center? It is somewhere in between. So it is on x-axis, right? So coordinate should be zero. The center is sigma xx plus sigma yy by 2, 0. Now we know that there is some tau xy So this is the tau xy. This is corresponding to even plane. So if I join this gives me even plane. And even plane is, if you remember the formula of Mohr circle, it is at an angle 2 phi. Okay, so this is the even plane, and this length will give you the radius. So if I take this radius and if I draw a circle considering the center at this point, I will get something like this. Okay. Now you can also find the radius using the formula sir has given in the class. Sir has given one formula in the class, but if you don't remember that, just remember this is tau xy. Okay, and this length you can calculate. What will it be? This will be sigma xx minus sigma yy by 2. So your triangle is what? So it is always better to remember the formula. But if you don't remember in exam, don't panic and just do. This is sigma xx minus sigma yy by 2. Use Pythagoras theorem and you will get r equal to root over sigma xx minus sigma yy by 2 whole square plus tau xy square. Similarly, you can find this angle 2 phi. So what will be tan 2 phi? Tan 2 phi is tau xy by sigma xx minus sigma yy by. It's quite easy. Just remember this diagram and you will be able to find that what is the radius, even if you don't remember the formula. Now, if you go back and look at the formula for the stresses like sigma, so I will just write it there. So if you remember the formula, we had sigma equal to sigma xx plus sigma yy by 2 plus r cos 2 phi minus 1. And for tau, we had r 925 minus. So what does this mean? So if this is our even plane, then for going for the plane which is in a counterclockwise direction at an angle alpha from even, on Mohr circle, we will have to move in clockwise direction. You can see the minus sign here. Okay, so the even plane will be somewhere here. This thing is tau x. This is our new plane, E alpha plane, I will write. Or should I just write alpha plane? Okay. So this angle is 2 alpha. This will be your tau, and this will be, let me use some other color. This will be your sigma. Huh. So I hope till now everything is clear. Now comes the concept. We will also solve some problems on Mohr circles. Now comes the concept of Mohr's plane. And of course, one thing I forgot to mention is this is lambda 1, this is lambda 2. This is the tau max. So this point will be lambda 1 plus lambda 2 by 2, comma, this is tau max. Tau max equal to R. Tau max equal to R. This formula can be simplified as 2 tau xy because the 2 from the bottom will go up. Sigma xx minus sigma y. I hope it is clear till now. Soon we will solve some problems. So more stress plane. This concept is required so that we can like find the stress and like sigma and tau, the normal and shear stress on any plane. Because with Mohr circle, there was one limitation that your planes had to be aligned such that or your new coordinate system should have been aligned such that one of them would have been in the direction of at least one of the normals of the principal planes. So we start with sigma matrix, which is of this form. This form is chosen just for the simplicity. There is no other reason. Suppose, and there is one other assumption that lambda 1 is greater than lambda 2 is greater than lambda 3. Lambda 1, lambda 1, lambda 1, lambda 2, and lambda 3 are what? You can see from the form that these are the principal stresses. Principal stress. I hope you remember the what was principal stress, what was principal plane. So if what will happen if we want to draw the Mohr plane? Okay. So lambda 1 is the extreme value of sigma. So the circle will start from here. Lambda 3 is the, so on lambda 1, lambda 3, when we consider suppose even E3 plane, or suppose we consider that, first we consider that we are given a stress matrix of this form. So there we will draw a circle related to lambda 1, lambda 3 only, right? Because lambda 2 is something else. Maybe I should draw it somewhere here. So in that case, this is our Mohr circle. Suppose we consider a stress matrix where E1 was aligned to, E1 was aligned towards one of the normal. So there the Mohr circle will be like this. And suppose if we were considering E3 to be aligned towards normal, so this will be our Mohr circle, right? So here the point is lambda 2. So if you follow some of the books, you will be able to find that this is the reason, like this shaded region is the reason which is Mohr's stress plane. So here you can take any generic stress matrix, sigma xx, sigma yy, sigma zz, sigma yx, zx. So sigma yx, sigma yy, sigma yz, sigma yz, sigma zx. So you can take this matrix and you can like, so this, suppose if this is your E1, E2, E3 now, you take an angle alpha and all whatever we did, and we can find that what will be the sigma and tau. Those will lie on this plane. Somewhere here. Now special cases. Suppose lambda 1 is greater than lambda 2 equal to lambda 3. Then what will happen? This is lambda 1, this is lambda 2 or lambda 3. Both are here. So in that case, your solutions will lie on this circle. On this circle only. You can imagine this also, that why only this circle is like this part is not the inner part or the outer part is not the solution. Only this circle is the solution. Now imagine lambda 3 is coming towards this place, lambda 2. So what is happening? This is solution for Mohr's plane. OK, so this space, it is contracting. Suppose if lambda 3 was here, we will have a, let me show you using. Suppose if lambda 2 and lambda 3 are very close, then what will happen? This is lambda 1, this is lambda 2. Suppose this is lambda 3. Circle will be something like this, and there will be one other circle. So you can see this is the, let me shade using some other color. You can see that when lambda 3 and lambda 2 are very close, lambda 3, lambda 2 and lambda 3 very close. So the shaded region, this has become very small, like very close to this circle. Now, what will happen if we move lambda 3 more towards lambda 2? This outer surface, this will collides with this inner circle, right? And thus our Mohr plane will reduce to a circle and the components will lie on this circle only and no other place, on this circle only. Now another special case is, what if lambda 1 is equal to lambda 2 equal to lambda 3? So in that case, what will happen? Lambda 1 is here, lambda 2 is here, and lambda 3 is here. So this is our Mohr plane will reduce to a point. Okay. So all the region of a Mohr plane will reduce to a point. Reduce to a all are the same. And what will be the tau? So at any point, so if somebody asks what will be sigma on any plane, so sigma will be lambda 1. And what will be tau? It will be 0. So this is the case of what? Hydrostatic loading. In hydrostatic loading, you take any point or any plane. You have the same loading minus p. And all the off diagonal terms are 0, like all the taus are 0. Now let's move to stress invariants. There are 3 invariants. I1. This is what? Trace of sigma. That is sigma xx plus sigma yy plus sigma zz. If we want to write in terms of principal stresses, then lambda 1 plus lambda 2 plus lambda. This is equal. Second is I2. This can be written as, let me refer the formula. So I2 is sigma 22 sigma 33 plus sigma 22 sigma 11 plus sigma 11 sigma 33. Okay. Minus shear components sigma 12 square, sigma 13 square, sigma 23 square. If we want to write it in terms of principal stress, then in principal stresses, what sigma 12 is 0, sigma 13 is 0. On principal plane, sigma 12, sigma 13, and sigma 23 will be 0. So we will be left with lambda 2 lambda 3 plus lambda 2 lambda 1 plus lambda 1 lambda 3. This is our height. And what will be our I3? I3 is determinant of sigma. So this will be lambda 1, lambda 2, lambda 3 in case of if we want to write in terms of principal stresses, because on principal plane, our matrix is our diagonal matrix. Now, if you want to write the Cayley-Hamilton in terms of like there is a theorem called Cayley-Hamilton theorem. You must have read in class 12th that if you find the eigenvalues to find the eigenvalues of any matrix, you have to do determinant of A minus lambda I equal to 0. And from there, you get a nth order equation, an nth order polynomial, and this order n will depend upon the size of the matrix. So for 3 cross 3 matrix, the n will be 3. So we will get a cubic polynomial. In our case, sigma is a 3 cross 3 matrix. So we will get a cubic polynomial. So that polynomial, we can write it as lambda cube minus I1 lambda square plus I2 lambda minus I3 equal to 0. This is called what? Cayley-Hamilton theorem. One property of Cayley-Hamilton theorem is the parent matrix itself satisfies this equation. So Suppose if this was a Cayley-Hamilton theorem for matrix A or matrix sigma, so this will also be true. Here I should write identity because this has become a matrix equation now. So the matrix itself will satisfy. So this is the characteristic equation, not Cayley-Hamilton. Characteristic equation for matrix sigma. Okay. And Cayley-Hamilton theorem says that the matrix itself will satisfy the characteristic equation. Characteristic equation. This equation comes in handy when you try to find derivatives of this sigma tensor, or you want to find the inverse without inverting the matrix. For example, if you want to find the inverse of sigma, how can you do this? So we can do this by, suppose if I take this I3I on the right hand side, so what I have I3I equal to sigma q minus I1 sigma square plus I2 sigma. I will post multiply by sigma inverse, so I will get I3 sigma inverse equal to sigma square minus I1 sigma. So sigma inverse will be what? 1 by I3 sigma square minus I1 sigma plus I2 I. So inverting a matrix is a very costly affair, and if a matrix is non-singular, then it's better to use this. So I1, I2, I3 were the invariants of stress. So this means that if suppose if we had found a new stress matrix representation in some other coordinate system, in those system also these will be equal. Like I1 will be equal to the same value sigma xx plus sigma yy plus sigma zz. I2 will be equal to whatever I have written here. I hope this is clear to all of you. Now the concept of octahedral stress. Octahedral stress. I'll just give you the formulas and move on. So to find sigma, the formula is I1 by 3. That is, remember these octahedral stress planes, they are with respect to principal planes. So the angles are with respect to principal plane. Always remember that. So okay, and tau is root 2 by 3 is square root of I1 square minus 3I. We will solve some problems related to this also. Shouldn't be an issue. Now hydrostatic and deviatoric part. We can write a stress as So I1 is the first invariant of sigma, that is trace of sigma. So if you want to write in terms of like in matrix form, you will find that this will be what? I1 by 3, 0, 0, 0, I1 by 3, 0, 0, 0, I1 by 3. And this will be sigma xx minus I1 by 3. This is called hydrostatic pass, hydrostatic part, hydrostatic part, because this resembles the pressure application like of hydrostatic fluid. This is called deviatoric part. Deviatoric. Changes volume. Doesn't change shape of volume. It doesn't change volume of body. Changes the shape of body. Trace of one more thing you can remember is trace of deviatoric part. I will write d equal to 0. Okay. So trace of deviatoric part will be 0. And trace of this will be, and trace of hydrostatic part is what? I. We should remember that this should be equal to the trace of sigma. Now let's move on to do some problems. Maybe I will take a sip of water and then we can continue. The question 2, 3, 5, 6, they are in your assignments. I won't be able to discuss them. Also, while asking any questions, please do not ask any questions which are still on the active assignments on the NPTEL. We are not allowed to discuss those questions. So the first question is, how much is the value of normal component of traction on an octahedral plane? So we have seen that the value is what? I1 by 3. So 1/3 of stress of trace of stress matrix is the answer. 3, 5, 6. What can you say about hydrostatic part of a stress tensor. So it is proportional to identity, of course. Its diagonal term is the same as the traction on octahedral plane, of course, I1 by 3. I have already shown you. See, this is the sigma octahedral. I should write OCT here. You can see the diagonal term is I1 by 3. Hydrostatic part is always 0. Wrong. It is stressless. Wrong. So answers are B and C. Which of the following of the stress matrix? Oh, I cannot discuss that. This has been asked. This is false. The points will lie on the circle. I have already discussed it with you. Maybe let's see if I can. I've discussed that why it should lie on the circle. The question is the state of stress is at a point is given below 100, 100, 400. What will be the equivalent pressure at this point? So this is a tricky question. I think a similar question was asked by Kiran last week. So we are given sigma xx equal to 100, sigma yy equal to 100, and sigma zz equal to 100. So the pressure equivalent will be. So first you find the hydrostatic part, like how much will be the hydrostatic part. So sigma octahedral or sigma hydrostatic will be, sorry, not octahedral, it will be hydrostatic. Mistake here. It should be 400 here. Sorry for that also. So hydrostatic part, let me write it as sigma h is I1 by 3, 100 plus 100 plus 400 by 3. So it's 200. Now equivalent pressure, what will be pressure? Pressure is the negative compressive thing. So equivalent pressure will be equivalent pressure. Let's say it's P. It will be minus sigma h. So it will be minus 200. So the answer will be the B part. How much the shear stress when the body is in hydrostatic state of stress? So the shear stress is 0. Always 0. This has been discussed since class 1, so you can refer to those lectures also. Question 10. If the principal stresses at a point in a body are sigma 11 equal to 100 MPa, sigma 2 equal to 0 MPa, and sigma 3 equal to minus 30 MPa, the maximum shear stress at a point will be. So there are many ways to solve this problem, and the easiest way is to just use the formula. So, sorry, this is question 10. Question is this is question 10. Question 10, they have given what? Lambda 1 is 100, lambda 2 is 0, and lambda 3 is minus 30. Lambda 1 is 100 MPa. Lambda 2 is 0 MPa. And lambda 3 is minus 30 MPa. So tau max is lambda 1 minus lambda 3 by 2. So it will be 100 minus 30 by 2. 65 MPa. Students make a mistake of doing sigma 1 minus sigma 2 by 2. But the thing is, on 1-2 plane, that is the maximum shear stress. But overall, if you look at, then you have to find the difference of like all three sets. Like you have to find sigma 1 1 minus sigma 2 2. You have to find sigma 1 1 minus sigma 3 3. You have to find sigma 2 2 minus sigma 3 3. And out of those, whichever is maximum, that you have to take. So ideally, we are considering in our analysis that lambda 1 is greater than lambda 2 is greater than lambda 3. So ideally, lambda 1 minus lambda 3 by 2 will be your answer. Now question number 11. They have given you a stress matrix. The following state of stress exists at a point in the body, and the stress matrix is 2 4 0 4 4 0 0 0 6. They want you to find the principal stresses. They want you to find what is the component of traction on a plane whose normal lies in XY plane and makes an angle 45-degree clockwise from x-axis. And they have told not to use Mohr circle. Then third question is, what is the maximum shear stress at a given point? And then they are telling you you can use Mohr circles. So first we can find the principal stresses. How do we do that? We find eigenvalues of this stress matrix. They have given this sigma. So the eigenvalues, how will you find? Determinant of sigma minus lambda I equal to 0. Let me check if I'm writing the correct. Yeah. So determinant of two minus lambda this is 0. So what can we do? We can find the determinant by 6 minus lambda into 2 minus lambda into 4 minus lambda minus 4 into 4. Now, what I did, because these columns and these rows were 0. So I opened this. I found determinant by using third row. So otherwise, suppose if I had followed the first row, what normally students do, first I have to write 2 minus lambda into this product, then minus 4 times whatever the way it is. Okay. So you can do either way, it's up to you. It's hanging a lot, so let's save it. So let's solve this 6 minus lambda into so one of the eigenvalues is 6. You can see directly from here. And I will talk about this after I solve this part. Lambda square minus 6 lambda minus 8 equal to 0. So if you solve this, you will be getting lambda equal to 6 plus minus square root of 36 plus 32 divided by 2. This is 6 plus minus. This is 3 plus minus root 17. Three plus minus root 17. So our stresses are root 17 is about 4. So our lambda 1 will be what? 3 plus root 17. Lambda 2 will be 6. And lambda 3 will be 3 minus root 17. Now look at one thing. Here last term was 6 and all other things were 0. So this means that the third E3 itself was a principal plane. The plane with E3 as normal itself was a principal plane. So we could have directly wrote that lambda equal to 6 is one of the eigenvalues. Okay. Now let's see if we have that in option. Yeah, so we have our first option. So this is the correct option for principal stresses. So we have found the principal stresses. What did we do? We found the eigenvalue of this sigma. Now the second question is, what is the normal component of a traction on a plane whose normal lies in xy plane and makes an angle 45 degree from the x-axis? Okay. So what they have given you normal. So is this the second part of question number 11 or it's the B part? So the A part is solved. This is A part of question 11. B part is they have given you that this normal is here and it makes angle 45 degree. This is our X, this is our Y. And let us say this is our Z. So this normal is in XY plane. So we can write N as cos theta E1 minus sin theta E2. 1 by root 2 E1 minus E2, or in column form. In column form, it will be 1 by root 2, 1 minus 1. So now we have our normal and we need to find the normal component of traction on a plane. So first we find the traction. What is traction on a plane with normal n? So this will be sigma n. So 2440 x into 1 by root 2. Oh, sorry, here it should be 10 also because we are dealing with a 3D problem, right? So into 1 minus 10. So this is what 1 by root 2 is here. 2 minus 4. 4 minus 4. This is 0. Now the normal component of traction will be sigma n dot n or Tn dot n. So 1 by root 2 minus 2 0 0 dotted with 1 by root 2 minus 1. Sorry, 1 minus 1 0. The dot product can be written as what? A transpose B. So I will take 1 by root 2 is common and A transpose will be what? Minus 2 0 0 into 1 minus 1 0. So the answer is minus 2 by 2. So minus 1. So the normal component will be a compressive and the answer is 2 minus 1. Now they're asking what is the maximum shear stress at the given point. Now, how do you find the maximum shear stress at the given point? They have written that you can use Mohr circle, but if you remember correctly, but if you think you will be able to find that what if I do lambda1 minus lambda3 by 2? That will give me the radius of Mohr circle, and that is also the value of the maximum shear stress. So the answer C is what? Lambda1 minus lambda3 by 2. So the answer is 3 plus root 17 minus 3 minus root 17 divided by 2. This is what 2 root 17 by 2. So tau max will be root 17. So answer is root 17. So this is the answer. I hope these questions are clear to you. I have tried to go in depth and discuss each of them. Now we will move on to subjective problems. This is the same PDF which is available on SIR's website. So I'm using the same PDF. You can go and download from there. This is lecture 10. Now we will move on to subjective questions. So the first question is, the stress tensor at a point is given by the following matrix in Cartesian coordinate system. Draw the Mohr circle corresponding to this state of stress on planes whose normal lie in XY plane. What are the principal stress components and corresponding principal planes? What is the maximum shear traction and on what plane does it act? Using Mohr circle, find out the normal and shear tractions on a plane whose normal lies in XY plane and makes an angle 7.5 degree from the x-axis in clockwise direction. So here they have asked you to draw a Mohr circle. So first we have to make sure that the stress tensor which they have given, is it even eligible that we can draw a Mohr circle? So can we find any of our axes which are aligned towards the normal of one of the principal planes? So yeah, so E3 is aligned with the normal of one of the principal planes. Okay, so let's move on and let's draw a circle, a Mohr circle. So I will just remember this -4, 4, -4. So we are given -4, 4, 0, 4, -4, 0, 0, 0, 3. I hope you people, whenever you like read the subject, you realize that stress, like the stress matrix representations which we are taking, they are actually symmetric because we need to satisfy A and B. So you can see it is symmetric here. Now to draw Mohr circle, what we need sigma xx. So what is sigma xx? -4. What is sigma yy? This is -4. Sigma xy or tau xy is what? 4. Sigma zz is 3. Maybe graphical background will give us a better picture. So what did we do? What did we do? We plotted sigma xx here and we wrote tau xy. That is minus 4 comma. This is our radius. Okay. Now you can see that the center, it itself is lying at the same point. Sorry, we did not find the center. I'm so sorry. So sigma xx plus sigma yy by 2 is the center. Let me find. So what is it? Minus 4 by 2. This answer is minus 1. The center lies here only at minus 4 because sigma xx and sigma yy were same. So this is our center minus 4 comma 0. Thus, directly our radius becomes the tau xy. So this plane is what? This is even plane. So if we draw a circle, so this will be our Mohr circle. The extreme point is what? 0 comma 0. This point is what? This is minus minus 8 comma 0. So this is lambda 1, this is lambda 2. The radius is what? Radius is 4 units. Maybe let's see if they have given the units. They have not given any units, so we will write radius as 4 units. So they are asking what are the principal stress components and corresponding principal planes. Draw a Mohr circle corresponding to this state for traction on planes whose normal lie in XY plane. So we have principal stress components as you can see lambda1 because we have a habit of writing lambda1 as the maximum stress. So I'm writing it here like that. So I should update the notation. It should be lambda2. It should be lambda3. Okay. So lambda1 is 3 MPa, lambda2 is 0. I'm assuming that they have given it in MPa. So here also maybe I should write MPa. Now the question is completed because we have in units. Lambda3 is what? Minus 8 MPa. Now the first principal plane, this is E3 plane. First principal plane is E3 plane. You can see E3 plane is one of the principal planes. The second principal plane, how do we find? So from E1 plane, we have to move at an angle 90 degree, right? So in a clockwise direction. So second principal plane will lie where? Second principal plane lies at an angle alpha equal to 45 degree, 90 by 2. I should write 90 by 2 so that you not get confused while revisiting the notes. Angle 9 alpha equal to 90 degrees. Right. Alpha equal to 90 degree by 2, that is 45 degree clockwise from, oh sorry, counterclockwise, not clockwise, because on Mohr circle we have moved clockwise. Okay, so here we should move so if on Mohr circle you move clockwise, that means in reality you have moved counterclockwise. Counterclockwise from E1 plane. Okay. Now where is lambda3? So for lambda3, you have to go all the way 270 degrees. So third principal plane lies at an angle alpha equal to 270 by 2, which will be 135 degrees. Now, did you move clockwise from even plane to lambda3? Yes, we moved in a clockwise direction in Mohr circle. So we should move counterclockwise in reality. So counterclockwise from E1 plane. So this is we have found lambda1, lambda2, lambda3. Another method to find lambda1, lambda2, lambda3 would have been to use this. What should I say? The determinant of sigma minus lambda I equal to 0. Okay, so that would have been the other method. But from Mohr circle, it is clear that where is lambda2, where is lambda3. Now the other parts are the corresponding principal planes we have found. What is the maximum shear traction and what plane does it have? Okay, So you can see maximum shear traction is at this point only. This is the point of maximum shear stress. Though it doesn't look like in the picture, maybe I can redraw the picture. Thing is wrong with my pen. So this is the maximum shear stress here. So this is what this is minus 4,4. Even on E2 plane, you can see it is minus 4, minus 4. So if by magnitude wise they are same. So maximum shear stress will lie on E1 plane only. Maximum shear stress lies on E1 plane. So the first part of this question is done. Now we have using Mohr circles idea, find out the normal and shear tractions on a plane whose normal lies in XY plane, making an angle of 7.5 degree from the x-axis in clockwise direction. So the x-axis is basically E1 axis. So part B is you have one E1 axis. You have E1 axis here. And they're telling that the normal makes an angle 7.5 degrees. So on Mohr circle, what will happen? On Mohr circle, move counterclockwise. First, what should I remember? I should move counterclockwise from E1 plane. Okay. This is the first step. How much do I need to move? I need to move 2 times 7.5 degrees. So this is 15 degrees. Now our Mohr circle was what? This was our Mohr circle. This was our Mohr circle. Okay. This was our Mohr circle and the points were this point was minus 4, 4. This was 4, minus 4, minus 4. This was 0, 0. And this was minus 8, 0. This was our E1 plane. We have to move 15 degree. And this point was minus 4, 0. So we have to move 15 degree. This is what? This is the plane of consideration where we want to find our sigmas. Plane of consideration. And if we find this sigma tau, we will be able to find our solution. So basically we have a triangle. If we look at it trigonometrically, this point is sigma comma 0, and this is 75 degree. We can directly use the formula derived earlier. We can use this formula. We can use this formula. We know the R is 4. We know sigma x plus sigma y by 2 is -4. So we can directly use, and for 2 phi, what will be 2 phi in our case? It will be 90 degree. So -4 plus radius is 4, cos 75 degree will be sigma. And similarly, it will be 4 sine 90 minus 15, that is 75 degree will be tau. So our answer will be sigma equal to -4 plus, maybe I should write that formula also. 2 phi is what? 90 degree. 2 alpha is 15 degree. So what should I consider, plus or minus? Which should be here? So you can see we are moving on left side, so it should be minus sign. So our formula which we will use will be sigma xx plus sigma yy by 2. Something is utterly wrong with my system. Minus r cos 90 minus 15. So this is what? This is -4 minus 4 cos 75. So what is cos 75? So sigma is what? The unit is MPa because I have considered MPa while writing here. And tau is r sine 2 phi minus 2 alpha. So 4 into sine 75. So this is 3.8637 MPa. So question 1 and question 2 are done. I will take a small break, of 7 minutes, maybe 5 to 7 minutes. Then we will continue to the second question. And if we still have time, then we will discuss something about strain. Otherwise, we will discuss it in the next week, because in the first week, only few topics have been covered. Okay. So let's move on to our second question. This is a similar kind of problem, but there's slight difference. So let's solve this problem also. I hope this question was clear. Now the subjective question number 2. We are given a state of stress -7, 6 root 3, 6 root 3, 5, and 3. So we are given sigma equal to and they're telling that draw the Mohr circle corresponding to this state of stress in XY plane. Why they are telling in XY plane? Because the third plane Z plane is in the direction of principal stress plane. Okay. What are the principal stress components and the direction of principal planes? What is the maximum shear traction and what plane does it act? The first question is similar to what we had done. So let's quickly draw it. So what is sigma xx? First step, write sigma xx -7. Sigma yy is what? 5. Okay, then tau xy is 6 root 3. What can we do here? We can directly write sigma xx as, so we can find the center. Center is what? Okay, in this question, I'd like to mention one thing in the previous question. So here I use this formula, right? Use this formula. What if you don't want to use this formula? Then also you can see that you have this triangle here, right? You know what is this triangle? This triangle is what? You knew that you have R here. This is R. You knew that this angle is 75. I was going through that method also, then I forgot to mention. Now you know that this is sigma. And what is this? This is -4, 0. This is what? Sigma common. Tau. Save it. So from normal trigonometry also you could have solved that, because this will be what? Sigma -4. So sigma plus R cos 75 will be this length. R sin 75 will be this length. So you could have solved using that. Maybe in this problem I will solve using that so that you get a hang of it. The center is -7 plus 5 by 2. So what is this? -2 by 2. This is -1. I will use scale. Wait. So what do we do? First we make sigma 1, 2, 3, 4, 5, 6, 7. So this is my sigma xx minus 7 comma 0. This is my center minus 1 comma 0. 1, 3. This is my sigma y comma 0. Okay. Now how much tau xy is given? It's given 6 root 3. So that will be around 10.39. 6. Somewhere here. Maybe I will move it slightly. So this is my so what do I get? This is my even plane. Even plane. This is the radius. This is what sigma xx. So now we have center, we have a radius, we can draw our circle. So this is our circle. This is our circle. This is what? Sigma xx comma tau xy. This is our angle 2 phi. Now what are the now we can find the radius, of course. So radius is what? So to find radius, you can use Pythagoras theorem. You know this is 6 root 3. You know this is minus 1 minus 6. So this is 6. So the radius is 6 square plus 6 root 3 whole square. So it is 36 plus 108 square root. So R is what? Square root of 144. Radius is 12 units. Now, how do you find? You already have one of the stress components, like, okay, so this will create problem for me later. We already know one of the principal stress components, it is 3. And we can see that lambda 1 will be somewhere here. So we know that this 3 is lambda 2. So what is our lambda 1? Lambda 1 is what? Center is at -1 and the radius is 12. So -1 plus, so the total distance will be 13. So lambda 1 is 13 units. Sorry. Lambda 1 will be 11 because here it is -1 and the total length is 12. So from here to here, the length is 12. So the unit here will be what? The coordinate will be 11, 0. I'm sorry for the mistake. So lambda 1 is 11. Lambda 2 is 3 and lambda 3 will be what? 13, -13. You can see here it is -1 and if you go 12 units from left of this, you will reach at -13. Now, what are the angles between like even plane, E2 plane, and like what are the angles at which principal planes lie? So this is corresponding to lambda 1. So lambda 1 lies at angle 2, 5. And how do you find angle 2, 5 here? So we can find this angle. Suppose this is something beta. So beta equal to tan inverse 6 root 3 by 6. So beta is what? Tan inverse root 3. So beta is 60 degree. This means 2 phi is pi, sorry, 180. Because I'm using degree in degrees, I should not write pi. So it will be 2 pi. So 2 phi should be 180 minus 60. So that is 120 degree. 2 phi is 120 degree. So to reach this plane, this first principal plane, this is lambda 1, this is lambda 3. To reach lambda 1, I have to move 120 degree clockwise on the Mohr circle. So where is the location of lambda 1? In reality, it will be alpha equal to 120 degree by 2. That is 60 degree counterclockwise from. So CCW is counterclockwise. CW means clockwise from E1 or X plane. Okay. Lambda 2 is on E3 plane. It is known. And lambda 3 will be what? Now, after moving 120 degree forward, I have to go 180 degree more. So lambda 3 will be what? This is 150 degree counterclockwise from E1 or X plane. Okay. I hope I'm clear. Now the second question is using Mohr circle, find out the normal and shear traction on a plane whose normal in XY plane and makes an angle 15 degree from X in clockwise direction. So you already have seen a method, but I would like to show this again because last time I used the formula. I don't want to use formula here. So the B part they have given you that this is even and this is 15 degree. So 15 degree clockwise. OK. So on Mohr circle, what will happen? On Mohr circle, we need to move in counterclockwise direction. So we move 2 times 15 degree in CCW from X or E1 plane. OK. So this is what we will do. So if we move in 30 degree, so the triangle we will have is, we have this -1, 0. This is sigma, 0, sigma, tau. And this angle is what? 30 degree. Why is it 30 degree? Because this was our even plane. Even plane. This is our plane of consideration. Okay. And this is our x-axis. So this was what? 120 degree. This is what? 30 degree. And this, then how much will this be? This will be 180 minus 120 minus 30. So this is 30 degree. So, and we know R is 12. So sigma minus 1 . So if we find from the Mohr circle, this we have to find here. So the length of this will be sigma minus -1. Okay. That will be equal to what? 12 cos 30. Okay. So sigma will be what? -1. It's hanging again. So the coordinate of sigma will be what? Because we are moving in a coordinate system, we should write like this because we have considered sigma, 0. So sigma minus -1, and this will be -12 cos 30. So here it should be -1. Thinking about it. So this is the coordinate of sigma. Okay. And what will be tau? Tau is 12 sine 30. Tau is 12 sine 30. This will be what? 12 into 1/2. So this is 6. So we have found our second part. Find out octahedral normal and shear component of this state of stress. So for this, you have to find I1 and I2, and you have to just plug it into the formula. Decompose the given stress matrix into the hydrostatic and deviatoric part. For this, you just plug into the formula and you will get the solution. So if any one of you have any doubt, you can ask me, or I will end this session now. If anyone has any doubt, they can ask me. So I hope no. So since none of you are asking, then I'm assuming that you don't have any doubt. I will be ending this session now. If you have any doubts, you can ask us on the discussion forum through Swayam portal. Thank you, everyone. Thanks for joining. Goodbye. Good night. I hope to meet you again on next Tuesday from 6 to 8 p.m. Thanks a lot.